Hi guys, welcome back to Village Solution. I'm super excited to have you back with me here. Today we'll be solving a new question on the topic measurement of heat energy. And the question goes thus: how long will it take to heat 3 kilograms of water from 28 degrees Celsius to 88 degrees Celsius in an electric heater taking a current of 6 ampere from an EMF source of 220 volts? The SSC of water is 4,200 joules per kilogram per Kelvin. So this question is a very simple one actually, but let's just look at our parameters first. So we are given that the quantity of water is 3 kilogram. So the mass of water is 3 kilogram, and the theta one is 28 degrees Celsius, and theta two is 80 degrees Celsius. So the water is in an electric heater, and the electric heater is taking a current of 6 ampere. A current of 6 ampere from an EMF source of 220 volts. So the voltage is 220 volts. So, and this is the question now. And this question also, okay, our last our C is 4,200 joules per kilogram per Kelvin. I want to find the time taken. How long will it take? Find the time taken. Now, what you have to understand in this question is that we are still using the normal formula that says that heat loss is equal to heat gain. But in this case here, the heat is being lost by the heater, while the heat is being gained by the water. So it is the heat lost by the heater that the water uses to what? To change its own temperature. So to get the heat lost by the heater now, we have to use our formula from heat energy. You know, let's do a quick elimination here. In your secondary school one, you have been taught that current is equals to quantity of charge over time taken. Where we have, and when you multiply this, your quantity of charge will be equals to IT. And we know that our work done is equals to QV. When you bring this Q inside, so work done will be equals to, put the value of your Q here into your Q here. You have your, so let me say equation 1, equation 2. When you put your 1 into 2 now, you have ITV, right? So work done equals to IVT. So you can, from our Ohm's law again, from Ohm's law you have V equals to IR. You can get various formula of this W. Let me do something for you. So let's say we put in the value of our V as IR. Let's call this 3. So our W can be equals to, so our V from there is IR. You can say IR then T. So our work done will be equals to I square RT. Also, we can say that our I from here, if you divide both sides by R, you cancel R here. So I is equals to B over R. When you put it, let's say this is our 4, and here is what? Okay, let's put 4 into this one here, into this here. Put 4 there again. So you have W equals to, I is now V over R, then multiplied by V, then times T. This will give us what? W equals to V square over R, then T. So you can get all this formula by just changing the formula of various parameters. Now, this is electrical work done, but we know that the formula for work done and energy are always synonymous, because the amount of work done is the amount of energy required to do the work done. Do you understand what I'm just saying? The amount of the amount of work done is the energy required. It's also energy. Yeah, let's just put it that way. So we use same formula for work done and energy. So we can write our work done as the energy. And as you must have seen also that the units of work done and energy is same, which is joules. We use joules for both work done and energy because their values are always the same. Just like when you have your potential energy and work done also. The when you have your, let's say our object is here, and we now release object here to an height. um The work done in taking this object from here to this height here, it will be equal to the potential energy that this object will be having at this height here. Let's make a scenario. Let's say our mass here is 2 kg, covers an height of 2 meters, and our G is equals to 10. Now the work done taking this mass from here to here is mgh, which is 2 multiplied by 10 by 2, that is 40 joules. This is the work done in taking this mass from this point here to this point here. Also, the potential energy possessed by this object at this height here is what? Is still 40 joules, because the work done, as work is done against gravity, the work done will be converted to the energy of the object. So also we have it in other scenarios also, so that work done and energy, they are always equal, provided that there's no heat loss or air resistance, friction, anything of such. If there's no anything of such opposing the motion or opposing the free flow of the energy, they will always be equal. So in this case now, we can see our energy is equals to, and in this case energy equals to work done. So our heat energy will be equals to, we can take any of them, equals to IVT. Our heat energy is equals to I square RT. Our heat energy is equals to V square over RT. Now anyway we are given, we have to find, we are using heater. So to get the heat energy of the heater, because we don't know the C of heater, the best way we can use to find the heat energy of heater is by using these formulas here, which I have derived for you right now. So now let's now go back to our question and solve now. So the heat lost by the heater now is, we will pick either of this depending on what you are given in our question. In our question here, we are to find the time taken, and we are given the current and the voltage. So that is IVT. So, and here is the formula here. So we have to use this one for the question, IVT. So our heat lost by the heater equals to IVT, equals to the what? Heat gained by the water, which is MC theta. Let me change this. Yellow is not. So our I is 6 ampere multiplied by the V 220, and T is the what is unknown. Our mass is 3 kg. C 4200. Change the theta, that is 88 minus 28. So 220 multiplied by 6 equals to 1320 T equals 4200 multiplied by 3. That is 12,600. multiplied by 60. So 80, 60 multiplied by 12,600. So we have 756,000. Okay. So we have 1,320 t is equals to 56,000. Divided by 1,320. Our t will be equals to our t now will be equals to 572.7 seconds. 572 572.7 seconds. And this will be all for this question. Endeavor to like the video if you have learned one or two things. Also, if you haven't subscribed to the channel, endeavor to do so and click the bell icon so that you'll be notified whenever I drop a new educational video like this. See you again.